Oi, a diagrammatic approach to deep learning IO awareness. We're not going super in depth today on this or anything, but it's a cool little visual way to look at GPU kernels, basically. If you find yourself to be more of a visual learner, or just you think it'd be easier to communicate in this way, it seems like they have developed a kind of way to visually convey your GPU kernels and what's happening rather than having to just rely on pseudocode. And they claim, I don't know how legit this is, they claim that if they had, like, don't claim this directly, but they kind of imply this, that if they had thought of this visual methodology earlier, they could have used it to derive flash attention extremely easily, is the implication, anyways. So we're going to just skim through a little bits and do like a quick, less than a 101, if anything, and just show off a couple of these little pretty diagrams to see. I think this is probably the best page to look at to get a rough idea of what's happening. So they develop a notation that like refers to certain things. So for example, if you have a vector of length x, they use this pointing to the left triangle symbol to mean softmax. And if, for example, you have a matrix of q by x, then you apply the actual softmax operation just along the x dimension, right? So we're looking at, like, from left to right, what happens to these actual matrices. It starts off left, moves towards the right. Symbols mean different things, right? Really interesting little visual language they've laid out here. Here is mapmul. If you have a matrix of shape A by B, then one of shape B by C, of course, B is your inner dimension to actually accumulate across. And the way they convey this is you start off with a matrix A and B is these two horizontal lines labeled, and then the dashed line indicates different input matrix, like separated, and then separate matrix B by C shape, and the actual accumulation across B right there is your columns by rows, rows by columns, whatever it is, right? And so that your output is now matrix of shape A by C. So this is this whole visual language developed. I'm not going to give a tutorial or anything right now. Personally, I'm not a very visual diagram person, but they have a whole host of designations here. They also have a system for determining, for conveying different levels in the GPU memory hierarchy, such that it'll be help convey how many actual memory read writes are we doing to allow you to build increasingly more complex diagrams. So to look at memory read writes, let's say you have this more complex diagram up here. What's happening here? We start off with matrix of shape QX, and then we softmax along X, right? And this black to orange means black is HBM, orange is SRAM, right? So we move into SRAM, and every time we do that move, the transition from black to red, is we label the actual size of the read-write operation. And here you can see two so far, and then this is a naive bad approach, is they moved the QX out of SRAM back into HBM, and then from HBM back into SRAM. This isn't correct per se, but they're displaying how this actually the diagram works. And then you say, okay, I have a separate matrix of shape X by D, and we are going to mapmul, right, our X or our QX by our XD. So load them both into SRAM, and then we do our actual mapmul. That is this little combination right here with the dimension folding in on itself. And then we get as a final output, we write that back to HBM is our Q by D matrix, right? So with this diagram, we can then add all of these up and end up with our cumulative reads and writes. It goes more in depth on a whole bunch of stuff. And as you can imagine, for example, this was a naive algorithm we're just looking at. It would have made more sense to, assuming your actual SRAM can hold it, to never do this step, never move things back to HBM, and just go straight to the actual mapmul to fuse the operation. They get into all of that, and the way you describe that in the actual diagram is you would just erase this part, keep in orange the entire time, and load this into SRAM and move on, right? So you can actually visually convey what's happening in a GPU kernel. Here is the example of deriving flash attention. Again, not going to get super deep into it or anything. It looks like these are the queries and then must have keys and values down here, I would assume. Yep, so this is looks like a transpose right here would be this little squiggly, like the crossing them over, and then we do our the this loop of the orange right here is our matmul of queries and keys, and then for some reason this E conveys all of the softmax happenings, I would guess. Wait, no, triangle is softmax, right? Yeah, triangle is softmax because this dimension folds in on itself, this D, and then we have length of queries by length of our keys ends up with our actual these two lines going into there, and then we softmax along that dimension, and then again matmul fold back in our values, right? So they're basically deriving the forward pass of FlashAttention right here by just looking at it visually. Very cool stuff. They can even do stuff like grouped query attention. They have a whole thing for groupings and how you convey that, as well as multi-head attention right here. So we're not going to go super in depth on any of this stuff. I just want to show it off to you now that I've given you the basic idea of what this is. So at least you have to go teach yourself. Personally, I'm not a very visual person. I'm not going to do it myself. I went through enough of it to kind of get it, but I don't really plan on using it. If you're big into visuals, though, I think you would enjoy it. And before we close out of here, let's just look at a few bigger diagrams, right? Um, this looks like, I guess it's FlashAttention on Ampere, is what it seems like the whole process, maybe like a bigger um, I can't quite tell what's exactly happening here. They have streaming and a bunch of and deletions included in a bunch of stuff. So you can get crazy with your diagrams. Reminds me of electrical engineers, basically. But yeah, hope y'all enjoyed that. Go check it out if it sounds up your alley. And yeah, end of video. Don't forget to like, subscribe, comment, hit the bell, all the YouTube things. Join the Discord server, follow on Twitter, connect on LinkedIn, and consider supporting me monthly either through Patreon or by hitting that YouTube join button down below. For as low as $1 per month, you can get early access to my videos. Or if you're a one-time payment kind of person, hit up my Venmo. And if you want to borrow my brain for a bit, consider booking a paid consultation video call. All of those links are over in my link tree. And yeah, end of video.